Wake up. Gotta continue. The fuck? Dog outside the window was so loud, I don't know why. Okay. And we continue. Took too long of a break. And it was stupid. But it is what it is. It was fuck. Shouldn't have done it. But okay. So we get some bit set stuff going on, huh? Are we don't even know what we're doing. We're just creating a bit set. Okay. Okay. I'll do like 15 more minutes of learning and then a 45-minute quiz, and then I'll go to bed. I'm gonna go to bed 30 minutes early. Or hold on. 15 and then okay, so 12 minutes early. And then to catch up on a little sleep, maybe. Create function templates that use multiple type template parameters. Sure. There's another kind of template parameter, the non-type. Non-type? It has a fixed type. It's a placeholder for a constant value known at compile time, passed in as a template argument, meaning what? That it could be different types of constant expression values. So it could be an integral type, so any of the various signed or unsigned integers, an enumeration, whatever that is. Sounds like a multiple choice for at least an Unreal Engine enum, but no idea. A null pointer, so I guess a pointer that points to nothing. That way, if I have a pointer that points to a specific value and I want to kill it for a second, that way I can update it later and check it, I can have it point to null pointer. It can be a constant expression floating point type. Seems like any kind of pointer to an object, a function, or a member function. Seems like those are the three things that exist. So those are function pointers. Those are also function pointers that are member functions and objects. So any kind of variable, anything that stores, anything stored in memory seems like. Okay. And a literal class type? What does that even mean? A literal class type? So an integral type. Oh, so these are just different objects, I guess? So does this mean any... I don't know what a literal class type means. I don't know if that's just a literal value or what. Okay. A non-type template parameter. Oh, because in bitset we were doing that. Where else is a case of that? Wouldn't that be... Actually, I don't know. In... Oh, standard numeric limits, we pass it. It has some template action. I'm curious what IntelliSense tells me. Limits. Type name underscore ty. Okay, so it's not a non-type. Well, a non-type? Why is it called a non-type? Because it's certainly a type, but is the point that the shit's treated the same? No, it can't be, because I don't know what's similar among all these types. I mean, it seems like they're all probably numbers. Pointer is just like a number, a place in memory. Same with an integral type. Maybe same with a null pointer if that's just pointing to nothing. And then maybe I assume the same for the remaining two. But that's how I normally use it anyway. I just put in some variable, some value. We saw our value, not variable. We saw our first example of a non-type one for standard bit set. Okay. For standard bit set, the non-type template parameter tells how many bits. But I'm surprised it isn't just an unsigned int right there, a type name, whatever, or just a straight up unsigned int. I mean, I guess it's a const expression value. So if it must be const expression, then And I mean, that's probably the proof because we probably have to know how much memory to allocate for this thing at compile time. So we can't say put a variable in there instead of 8 and then call or something to get that variable from the user. Well, then it's known at runtime, not compile time, and it might not be happy. Let's see what happens. Or, well, we'll say get uint. Okay. And we'll just do okay. And then here, so this is known at compile time. At runtime, sorry. Okay, and then we'll say what have we got? So it seems like it wants to take an int in the template parameter something bits. Can't be used as non-static. Okay. So let's say it's const and it's just initialized to be what it is. Okay. Well, it needs it to be. Oh, well, this is a const unsigned int. Non-static. Oh, it needs a stat. So we can create it, but then it can't be initialized. Or, well, I guess it could. A static const value, maybe? It's not compile time. Well, it can't be known at compile time. So, I mean, what happens if I just put const expression? It won't work. Yeah, it's not evaluating to a constant. Makes sense? Okay. Basically, it needs a very specific type of value. It needs to be known at compile time. And what was it even wanting here? It was bit set. Size t bits. Still don't really know this shit. A non-type template parameter. Tells it how many bits. Okay. An integer non-type template parameter? What does that mean? Like it's a template parameter that isn't. This seems like it's just a regular S parameter. So why are we defining it in the template? And not just as a function or as a parameter in the print function? Seems like it would just be a regular parameter in the print function. Signature. Function that uses an int non-type parameter. type int a non-type template parameter of type int. So we do that, and we call print, and we give it 5. What the fuck? So instead of calling it and specifying the type, we're just giving it the value, and it already knows the type. What is the difference between that and just giving it a regular explicit specialization with a type int? So we just do a regular ass template, and we don't even need a template. What's the point? Well, I guess we're saying template int and then print as an int. What is the value here of putting this in the call here and not just as an argument? I don't know. I mean, it seems like and so we have a template, a type of something. Instead of it being a type name T, it's a float G void do thing. And it's cool with it. It sees that it exists. Instead of it being, what if it was type name T? It's because it's a placeholder, so it's probably expecting it. Or well, because this is the type. This is a placeholder type, and this is how the type is referred. Or T is used as the placeholder type, and type name is the type. Excuse me, it's the type of a type. It's what type the type is. So if we instead just say it's a float called G, and we just call it do thing G. Oh wait, bro. 4.3F. So there are some different type things going on. There are typed template parameters where we pass it a type. We say integer, and then we give it some values, and we're filling in for placeholder values. A non-type one is a template parameter that is not a placeholder type. It is instead an actual specific const expression type. And test is known at compile time and at the float. What happens if we do it with a standard string? Oh, there's a do thing. It has a standard string, and we're passing it that. If this wasn't a standard string, it was just an int. It would be cool. There's no function template that matches the argument. It must be of a structural class type. Standard crazy ass thing is not a valid type. Basically, standard string isn't compatible. Makes sense? Because we already saw that they had to be integral or floating point or similar shit like that. Size T. Maybe we spawn a number of characters. So we say template standard size T, or what do I have to do? Include size T has shit. Whenever we include an input and output, what if we do or C standard int maybe? Nope. Okay, so standard library has a size T. And it is void spawn enemies. Okay, and then it'll spawn the enemies. Okay, and we simply call spawn enemies 100 of them. Cool, and it will spawn 100 enemies. Interesting. And there, really, we should be doing size T, enemy number. Interesting. It's a template parameter that's non-type, meaning that it's passed as a value, not as a type. The type is already known in the template, and it isn't specified in the function. It's specialized. It's not defined in the function signature. It's defined in the template. On line 3, we have a template parameter declaration. Okay. Defining n, which is an integer, and it's a placeholder not for a type but for a value, and it's usable in subsequent functions. On line 11, we're passing it the template call, or the function. We're calling the primary template and passing it that non-type value. The int value is the non-type template argument, and we'll instantiate a function that looks like that. And so the point of taking it out of here and putting it here, I still don't really know. There's actually a lot of stuff in here. Go 4 more minutes and then the quiz. Use n as the name of an int non-type template parameter. Function parameters can't be const expression, so for in this case, when we want it to require a const expression value, then Maybe it means that it's more optimal. I don't know what the fuck a const eval function is. So we are calling get square root of 5 and -5. Okay, as doubles, literals. And in square root, we return a double and we take a double. We're asserting that the double we're passing is a positive real number and it can't be negative. So if it's not, if it's 0 or less, we get the standard abort. What? I'm not sure why there's a condition here. Oh. We want to return 0 for calculations that aren't right. So let's say this is in a video game, and in the video game you have a calculator, and you use the calculator to calculate the square root of -4. Well, I don't know what the fuck that would be. It seems like, I guess you can't get that, because nothing times itself gets a negative value. Unless we're talking, I guess, an imaginary value, maybe. I don't remember, honestly. I numbers. So, like, I squared is -1. I think that's how that works, but ignoring that, you have to do positive numbers. So, if we do a release build and the release build takes out assert via including ndebug, then if we just have return the square root, well, we're going to be taking the square root of some shit that's 0 or less, and maybe we get an error there. So, still want a condition. An if statement. So we do 5 and -5. Yep. Oh. Well, if we're doing non-debug, then it just will return 0. Yeah, true. We could just do static assert here. Yeah, sure. Because we're passing it these literal values, so we know everything at compile time already. But it requires a const expression, and the parameter can't be const expression. Interesting. So what happens if we do const expression can't be on a function parameter? Okay. However, if we change it to a non-type template parameter, then it can require it. So in that case, we can say, what would that look like? What did we include? We included assert, we included cmath, and we had template. We'll just do integers. Integer root target, we'll just say the thing that we're square rooting. And then we say we just return an integer, and it's get root or get square root of something. And we return, or we'll say if root target is greater than, or equal to, okay, sure, or equal to 0, then return square root target. And we're cool. We need main. But now we can just call get square root of 4. And now we're passing it as that. Well, in this case, we're passing an int. Square root is returning a double. But then we're returning a double as that. So I could just say auto here. And then I could just ignore this. I mean, we could say if const expression, and this is fine because this is a const expression guy, so I'm surprised it didn't error out for him there too. Oh, he did. Okay, makes sense. Cool. Okay, I'm gonna pause here. Say when, however, if we change the function, cool. All right, and I'll get perplexity running.